Okay, first, just a quick review of a couple, a topic from last week. So finding intercepts, right? All the Chromebooks should be closed all the way. So it's easy to find X and Y intercepts. We're going to review that real quickly, maybe a reason why we might do this. Okay, so what if I asked you to, let's say we're going to take this line right here, and I wanted you to quickly come up with a sketch of the graph of that line. Okay. What do you need in order to sketch a line? We've graphed some lines before, and the strategy has essentially always been the same. Right? Well, what did we end up doing? We get to what? Points somehow, right? We get 2 points, then we connect and extend. Depending where we start, if we're in slope-intercept form, a lot of times we'll just use the y-intercept as our first point, then make a slope triangle to find a second point. But ultimately, all we ever did was we just got 2 points, and then we connected and extended, right? Well, if that's all we need are 2 points to graph a line, we want to make our lives as easy as possible. So let's go ahead and pick the easiest ones to find, which are typically the intercepts. Okay. So real quick, if I want to find the x-intercept, remind me from last week, what's my strategy to find the x-intercept?
Subtract 4y equals x.
I mean, I could, but there's something that's making this even easier. What's true for every x-intercept? If I go on the xy plane, like if I make, just think about this for a second, without even worrying about those problems. If this is the xy plane, and I've got some random line that's crossing through both axes, and I'm trying to find the x-intercept, what can you, without knowing anything else, what's one thing you can tell me for sure? What's one coordinate you know for certain? What's that, John? Which one's 0? The y-coordinate's 0, right? Because the x-intercept is where the line crosses the x-axis. And every point on the x-axis must have a y-coordinate of 0, right? Because it's not up or down from the starting point at the origin at all, right? So we automatically know that's going to be 0. Okay, what about the y-intercept then? Same kind of deal. For the y-intercept, what must be 0? X. Yeah, the x-coordinate has to be 0, right? We don't know what y is yet, but the x-coordinate has to be 0 because it's lined up vertically with the origin, right? Okay? So our strategy then for finding the x-intercept is real simple, right? All we've got to do to find the x-intercept is set y equal to 0, and then solve for x, right? That's it. Okay, so let's do that in this equation. If I've got this equation up here, negative 11x plus 4y equals negative 1. If I set y equal to 0, it makes this equation pretty darn simple, doesn't it? If y is 0, then what's 4 times y? 0, right? 0 times anything is 0. So look, I could just cross out that term, and I can literally just cross it out, right? And cover it up and solve what's left. It's easy. What's the only step to solve for x there?
Divide by negative 11.
Say it again. Divide by negative 11, right? It's one simple step, and I solve for x. So that gives me my x-intercept. I set y equal to 0 in the equation and solve for x, and I'm always getting the x-intercept, right? So if I do that, x equals negative over negative is positive, right? So I just get the 1/11th doesn't simplify. So I get negative 1/11th. That means my x-intercept, if I want to write it as an ordered pair, is the ordered pair 1/11th, what? 0. Okay, well then, by the same token, what's my strategy for finding the y-intercept? set x equal to 0, and then solve for y. No big deal. So the same thing here. So Mackenzie, if I set x equal to 0, that makes this equation pretty simple. What's my solution going to be? If I solve for y? Divide by 4. Good. And so I just get y equals negative over positive is negative fraction, and then I just get 1/4. That doesn't reduce. Right? So if I write that as an ordered pair, my y coordinate is negative 1/4. What's my x coordinate, Gabe? 0. And that's it. Yes, sir. Yes. Okay? So that's it. Now, something like this one, honestly, is kind of a, I probably wouldn't even necessarily want to use this technique for graphing this line, but maybe I need to find the intercepts for other reasons. This would be, what form is that equation? Mx plus b, a slope-intercept, isn't it? So the easiest way to graph this one would be like we talked about before. I could take the y-intercept, which is -4, and then make a slope triangle where I rise by -4 and run by 3 and create another point, connect and extend. That'd be probably the easiest way to graph the line. But let's find the intercepts. Okay, same technique as before. Let's see, if I want to find the x-intercept, what am I going to do there? What am I going to do there? Hey, Lonnie, what am I going to do there? Find the x-intercept. What am I setting equal to 0 to find the x-intercept? Y. Good. So we'll set y equal to 0. Oh, whoops, that's... Okay, so I've got 0 on that side of the equation. Now this is just a little bit tougher. I've got to use 2 steps this time. But what would the 2 steps be to solve for x here? Add 4. Okay, so I can certainly add 4 to both sides. If I add 4 to both sides, we end up with 4 equals negative 4/3 x. Yes, sir. Yep. Okay, so what's next then? Okay, so to get the x by itself, I would divide by negative 4/3. But instead of dividing by fractions, what do we always do instead? It's a lot easier. Multiply by the reciprocal. There we go. Okay, so let's take this equation and let's multiply each side through by negative 3/4, right? I run out of real estate there. Let me come down here and rewrite this, give myself a little order. So I've got 4 equals negative 4/3 x. You multiply each side by negative 3/4. 4 is the same as what? 4 over 1, good. And now look what happens when I multiply these fractions. The negative times the negative becomes positive, good. The 4 and the 4 are going to cancel, 4 on top, 4 on bottom. The 3's cancel. It did exactly what it was supposed to do, didn't it? We end up getting, on the right side, we end up just getting an x. What about on the left side? If I multiply, I could either cross cancel. What if I multiply straight across? Negative 3 times 4 is negative 12 over 4 reduces to what? Good, so I'm going to get a negative 3 for x, right? Now I want to write that as an ordered pair. So my x-intercept is going to be, the x value is negative 3. What's the y value? 0. Okay, y-intercept, that didn't do anything. Molly, what's the y-intercept? That line. What form is it in? What form is that written in? Ah, Well, what's B? But what does B stand for?
Just
Y-intercept. So what's the y-intercept?
4.
-4, right? Now, we can find it pretty easily. It's not hard to do, right? If we set, what are my other,
I think you scroll down so it's spelled count.
what happened?
You scroll down so it's spelled.
Oh, there it is, yeah, thank you. Okay, if I set, oh my goodness, there we go. If I set, let's see here, one of these days. There we go. So if I set the, it's not centered very well, you get the idea, it's pretty bad 0, but anyway, you see my point. So if I set the x equal to 0 to find the y-intercept, it's pretty simple, right? All we're doing is we're just covering up, -4/3 times 0 is 0, and we get the answer right away, y is -4. Right, so we get the y-intercept. The y value is -4. Mackenzie, what's the x value of the y-intercept?
Oh, 0.
0. There we go. So there's my, right, we got them both. Okay, no big deal. Okay, so for today, all we're adding today's short day, we're adding almost nothing. This is it. It's a real important thing, but there's not much to it. So we've got, at this point, we've got 2 different ways of writing the lines. Let's just take a second and review this. So we've got slope-intercept form, which we all know. Oh, whoa. Almost got virtual ink on it. So slope-intercept form, what's that? Y equals mx plus b. And what's m? What's the meaning of m? Slope, what's the meaning of b? Y, what's the meaning of b? Y-intercept, good, okay. So we got the slope-intercept form. We also talked about standard form last week. What's that one? What's standard form? Dominic, remember what standard form is? I'll get you started. AX, remember? Plus BY equals C. Okay, good. So we had AX plus BY equals C. Now, what had to be true? A, B, and C didn't really mean anything nice. Like, they're not slopes or y-intercepts. They're just numbers. But what has to be true of those numbers?
Will it be divisible by 1?
Okay, so they have to be integers, right? Can't be fractions or decimals. So A, B, and C have to be integers. What else? A has to be positive. Good. Those are the 2 biggies. And then there's one more kind of tricky one. Greatest common factor has to be 1. And now what do we mean by that? Like, for example, what if I had something like this? What if I had 12x minus 8y equals 16? Is that in standard form? Almost. It looks pretty good. The A, B, and C are integers. A is positive, but what's the problem here? What's the greatest common factor of A and B and C? 4. Yeah, and when we say greatest common factor, we just mean the biggest number that divides evenly into them, right? So what would I have to do to simplify this, to put it into true standard form?
Divide by 4.
Divide everything by 4. Divide both sides by 4, and that would give me 3x, minus 2y equals 4. Now we're good. Okay, make sense? All right, so we got these 2 are really important, and we're going to actually write equations in both of those forms depending on what we're doing, right? Today, we're adding another one, but this one is not, it's not like we're ever going to really write answers in this form. This form is more of like a step in the middle to getting our answer. It's a convenient way for us to plug information in to come up with the equation of a line. It's called the point-slope formula, and here's how it works. If now you can. Okay, it just says this, to write a linear equation given the slope of the line, so if we're given the slope m, and a point that it passes through, now this is gonna look a little different, x1, y1. When we write something like that, where we say x, and that's a little subscript next to it, it's supposed to be a little subscript, so x sub 1 and y sub 1. A lot of times we just say x1 and y1. Whenever you see a number attached to a variable like that, what it's telling you is, it's talking about a specific value of that variable. So it's a number. It's a number value we're plugging in. So x1, y1, together those correspond to the coordinates of some point that our line passes through. Okay? Then we use point slope formula, which just goes like this. Y minus y1 equals m times x minus x1, where the red parts, the m and the x1 and the y1, are the numbers we're plugging in. Those are the values that describe our line. It's the slope and the coordinates of a point that our line passes through. Okay? So let's try number 1 here. What we always want to do is just kind of start off with point slope with the formula, and then we'll just plug in the information for our particular line. So we start off here with y minus y1. We always start here. Y minus y1 equals m times x minus x1. And what numbers can I plug in? Tell me one number that I can plug in here. Negative, so where's that going? For m. Okay, so there's one thing that's happening. I'm going to get a negative 4 there. What's another number I can plug in? Negative 1. Where's that going? For that's the x value, right? So that's going in for x1. So we're going to end up with x minus negative 1. What's that? Plus 1, right? X minus negative 1 becomes an x plus 1. And then finally, I'm plugging in the y value, right? Y1 would be 7. So I get y minus 7 equals negative 4 times the quantity x plus 1. So that's in point slope form right there. Okay, we just plug this stuff into point slope form, and that is the equation of our line. It's just not in a very good form. Right, what do we have to do to simplify this? What do you think, Rodney?
Oh, to simplify it?
Yeah.
Isolate y maybe?
We're going to isolate y, and that's all. When we remember what we said last week, and it's going to start having more meaning for you this week. But when we want to write an equation in its simplified form, in slope-intercept form, all we're doing is just isolating y and simplifying. Okay, so what are the steps here? What are some things that we can see that we need to do to simplify this? Everybody take a second and just see what, what's my ideas. What do you think? Sure. Go ahead. Take a second. What do you think? Some ideas. Nancy, you got an idea? Distribute. Yeah, so let's distribute the negative 4. There's one thing, that's a great idea. And the steps are always going to be the same. We're going to distribute the slope. And that's going to give us y minus 7 equals what? If I distribute the negative 4, what am I going to get? Negative 4x minus 4. Last step. What's the last step? Marcus?
Don't use the sign.
So what's
Carry
that?
over the 7.
So I add 7 to both sides? Okay. So if we add 7, then I end up with y equals negative 4x, and then negative 4 plus 7, those are like terms. What do they add to? What's the negative 4 plus 7? What is that? 3. There it is. Right there. Okay. So we're going to plug in using point slope, and then we're just going to simplify the equation. Yes, sir?
I saw on, was 2.3, the newest assignment, they wanted, like the first section of that, so they want it in points form.
Right, right. Okay,
Okay.
good. So the first part, so the first couple questions, we would have stopped right there.
Okay.
right? Because the first couple questions, oh, I mean, they're just kind of real basic. All you're doing is, on the first couple questions, you're just practicing plugging stuff into point slope. And then from then to get a couple questions of like this, where I want you to, I'm gonna give you a point and a slope, and I want you to write it in simplified form, slope-intercept form, okay? And then after that, the last two are like this. We're gonna use 2 points, and we'll get there in a second. Let's try one more of these with a point and a slope first. Okay? So everybody take a second and jump into this. Let's start off, everybody, and what I would recommend is, see if you can do this without looking on your paper. Everybody tell me, what is point slope form? Y
minus y1
1 equals times x minus x1. There you go. Right. So we always start there. Start there. Y minus y1 equals m times x minus x1. Take 20 seconds and see if you can figure out where everything goes there. Yeah. Okay, where's everything go here, first of all? So we'll. Kaylee, what am I plugging in for Y1? 5. Okay, and I'm subtracting -5, so what's that going to become? +5. Okay, good. So we get a +5 there. What do I put in for M?
2/3.
2/3. And then what about X1?
+6.
Good, it's gonna end up being a +6 because I'm subtracting a negative. Everybody agree? Okay, so there's point slope form. Good. Okay, so what's next? Autumn, what's next then? We got everything plugged into point slope. Now we're gonna try to simplify this and put it into slope intercept form. Distribute, good. So we'll distribute the 2/3, and that's gonna give us y plus 5 equals 2/3 x plus 2/3 times 6. Same thing as 2/3 times 6 over 1. So what's that going to become? 4. Good. And we could either multiply straight across and get 12 over 3, or if we wanted, we could cross cancel this and make that, when I'm multiplying fractions, I could do that, right? I could make that a 3 and that a 2. Either way, we're going to get y plus 5 equals 2/3 x plus 4. Last step. What's the last step? Kiara, what's the last step? Good, okay, subtract 5. Very good. So we'll subtract 5 from both sides. And we get y equals 2/3 x minus 1. We're done. No big deal. Okay. So what could we do then if we're given different information this time? What if we're given 2 points instead of a point and a slope?
Like in different spots. So,
What do you mean by that?
like, we have y and y1, because there's 2 different points.
Okay.
So, we could plug in, y and then y1, and then x and x1.
Okay.
Solve from there.
Good. Now, we need a slope though for point slope. What are we gonna do about the slope?
1 over 1.
It might be, but it might not be too. How could we gotta be able to fill all that stuff in, because ultimately we still have to get the point slope form. We still have to be able to plug in. I gotta be able to plug in values for the slope and for x1, y1. What do you think, Ted? I mean, I could graph it. What are you getting at though? Rise over run. Yeah, we could figure out the slope, couldn't we? We don't even necessarily have to do it from a graph. Right? We could, I've got 2 points here. Do you remember what the formula is for slope? If I've got two coordinates at 2 points. Now, so like this one we would call maybe, this one let's call x1, y1. And what are the ones for? Point number 1. These are the coordinates at point number 1. What am I going to call this one, do you think? X2, Y2. What's the 2 stand for? The second point. Okay. So what's the slope formula in terms of x sub 1, y sub 1, x sub 2, y sub 2? It's rise over run. How would I say rise over run using x's and y's? The y is going to be, if I'm looking at a graph here, right, and actually I'm going to make a little graph. I want you guys to make this connection. This is really important. So I've got some random line, and on the line I've got 2 points. I've got a point there and a point there. And I want to know what the slope is, right? Well, let's not even specify what these points are. I'm just going to say this is point number 1, so it's got coordinates. It's got coordinates x1, y1, and this guy up here has coordinates x2, y2, right? If I want to make a slope triangle out of this now, I'm going to rise by some certain amount, and I'm going to run by some certain amount. How much did I rise?
Whatever y1 is, right?
It's y1 is this value. Is this value right here, right? Because that's what these coordinates mean is from the origin I've gone over x1 to the right, and I've gone up by y1. What about over here? I've gone over to the right by x2, and I've gone up by y2, right? So what is that distance right there?
X1, Y2.
Ah, there you go, right? It's just y2 minus y1, isn't it? Isn't this distance right here just y2 minus y1? Would agree. That's all that is. How much did the y values change? The change in the y values, the final y value minus that starting y value, that's the rise, isn't it? How much the y coordinate is changing is really what we mean by the rise. Think if we had numbers here. If we had gone from something like what if this bottom point had been something like 2, 3, and the top point had been something like 7, 13. Something like that. What would my rise be? 10. I'm going from 3 up to 13, but that's 13 minus 3. It's just 10, right? What would my run be? 5. Going from 2 to 7. Well, that's just 7 minus 2 is 5, right? You get my point? So the rise is just going to be y2 minus y1. The run is just going to be x2 minus x1. And so there's our formula, right? We've got our slope formula that you probably remember from Algebra 1. Is just y2 minus y1 over x2 minus x1. And so what's our strategy then? We got 2 points. We can use the 2 points to calculate the slope of the line. Right? That's all it takes is 2 points to calculate the slope with our slope formula. Calculate the slope, and then I need to use one of those 2 points in slope-intercept form. Does it matter which one? No, it doesn't matter. Whichever one looks easier. Right? All I need is a point, a slope, and a point that the line's passing through. Okay? So let's do this then. If I want to calculate slope, what's that going to equal? Joseph, what's that going to equal? What goes on top?
Maybe -3 or +5.
Plus 5, good. Minus -5 over
1 minus 10.
10. Good. Everybody see that? Okay, and that's going to give us on the top -8 plus 5 is what? -3. 1 minus 10 is -9, and so negative over negative is positive, right? And 3 over 9 reduces to 1/3. Okay, I want to just prove a point to you. Did it make a difference? Now, and I don't want this to confuse you, but I want you just to see this. Did we have to subtract the left x and y values from the right x and y values? Because we called that one point 1 and that one point 2. It's probably the most convenient thing to do, but did we have to? No, didn't make any difference. We also could have flipped those around. I could have said, okay, well let's subtract these guys from those guys. Then I would have had -5 minus -8 is +8 on the top, right? And on the bottom, I would have had 10, this x value, minus that x value, and I'm just gonna get +3 over +9. Same thing, 1/3, yes, sir.
So not to be like a little stickler, but, how do you, like, when would we, in what real-world application would we find, like, y2 and x2 and y1 and x2, or,
So, okay, so there's,
yeah.
there's some really good ones, and I'm debating how much of this I wanna go into, because we're a little bit behind, but there's a topic coming up that I at least wanna show you guys. I don't know if I'm gonna make you do it necessarily, but I'm gonna show you an example of where this is unbelievably applied. I mean, it's something that happens all the time, every day, in any kind of an application where you use statistics. You're doing something called linear regression, which is exactly this.
Okay.
Yeah. And so, hold that thought, yeah. When are we out of here?
One.
Okay, good, we can finish this up. So then now we got a slope, right? All we gotta do is we're just gonna plug these values into point slope, okay? So what's that gonna give us? Jasmine, help me out here. I'm gonna plug in, what goes where? What am I plugging in for M?
The three.
The
Wait, no, 1/3.
1/3. Okay, so we got 1/3 going in for M. What values could I plug in for X and Y?
-5 or +5 and.
Okay, so I could put a +5 there, right? I could do that. I could go +5, and what would I do here then?
+10, or -10.
-10, everybody agree? Or what else could I have done?
The opposite.
I could have used these points too, couldn't I, right? I could have put y minus negative, I could have had just as easily a y + 8 equals 1/3 times x minus 1. And you get the same answer either way, right? And from there, all I gotta do is just distribute and add like terms. Okay,